Alright, in this video we're going to look at how we multiply rational expressions, and it's not very much different from simplifying. When we multiply two rational expressions, like the ones that you see here, what we're going to do is we're going to factor both of them completely, and then we're going to look for any factors where we have one that appears in one of the numerators and one that appears in one of the denominators, and we're going to cancel those out. So the first thing we're going to do in a multiplication problem like this one is we're going to factor numerators and denominators of all the rational expressions completely. So we factor the x squared minus 3x minus 4 times x minus 4 times x plus 1. And we factor x squared plus 3x plus 2. And that factors as x plus 2 times x plus 1. And then we factor the x squared minus 3x minus 10. That's x minus 5 times x plus 2. And then we factor the x squared minus 2x minus 15. And that's x minus 5 times x plus 3. And now we look for factors that appear in both the numerator and the denominator. We see an x plus 1 and an x plus 1. We see an x minus 5 and an x minus 5. And we see an x plus 2 and an x plus 2. One of each of those factors that appears in numerator and denominator, and so we're going to cancel those matching factors out from numerator and denominator. And this multiplication problem ends up simplifying to x minus 4 over x plus 3. Alright, this one says to multiply and find the restrictions. So we're going to first factor completely all of the numerators and denominators. And then we can factor a 10 out of everything here. And then we can factor an x squared out of everything here. And we can factor 2x out of everything here. And then let's see, this is x plus 5 times x minus 2. And we can factor the x squared plus 2x minus 3 more in the numerator on the left. That's x plus 3 times x minus 1. Instead of rewriting all of that, I'm just going to replace that with x plus 3 times x minus 1. And now we have both the numerator and the denominator completely factored in all of these. And we're looking for common factors to cancel. Before I cancel the common factors, I'm going to identify the restrictions. We have restrictions from every piece of the denominators because that's where we can have division by 0. And so my restrictions, x can't be equal to, let's see, I've got a negative 5 would make x plus 5 equal to 0. Positive 2 would make x minus 2 equal to 0. 0 would make 2x equal to 0, and negative 3 would make x plus 3 equal to 0. So those are all of my restrictions. And now I'm going to identify common factors to cancel. I can cancel an x plus 3 with an x plus 3 in the denominator, an x minus 2 in the numerator with an x minus 2 in the denominator. I can cancel an x with an x. That leaves one x in the numerator. And I can cancel a 2 out of the 10 and the 2, and that leaves a 5 in the numerator. And now I'm going to see what all I've got left behind. In the numerator I have 5 times x minus 1. And in the denominator I just have x plus 5. And so that is my simplified form of this multiplication problem with the restrictions. Alright, last problem. This one's a doozy. A lot of factoring going on here. Alright, so let's see. I've got 3x. I can take that GCF out of everything in the numerator here. And I can take a 2x squared out of everything in the denominator here. X squared minus 4x minus 5. And I can take a 4x out of everything in the numerator over here. And I can take a 5x out of everything in the denominator here. And now I want to factor the remaining polynomials in all of these. So I've got 3x times x minus 5 times x plus 3. I've got x minus 5 times x plus 1. Got x plus 4 times x plus 2. And I've got x plus 2 times x plus 3. Again, I'm going to identify the restrictions first here. X can't be equal to 0, 5, negative 1, negative 2, and negative 3. And now I've got some canceling to do here. Let's see, I've got an x minus 5 and an x minus 5. Got an x plus 2 and an x plus 2. Got an x plus 3 and an x plus 3. I've got an x and an x. I've got an x and an x. That leaves an x behind there. And I can take a 2 out of both the 4 and the 2. And now I'm going to combine all this back together to make our final form. Let's see, in the numerator I have 3 times 2 times x plus 4. So that's 6 times x plus 4. And in the denominator I have x times x plus 1 times 5. That's 5x times x plus 1. That was a pretty challenging multiplication problem. But if we follow through with our steps and take it nice and easy and step by step, we can make it a lot simpler on ourselves. Alright, that concludes our video on multiplying rational expressions.